Everyone, I'm Dashni. In this presentation, I'll explain how artificial intelligence, especially deep learning, can be used to detect plant disease automatically from leaf images. This project comes under Smart Agri 4.0, which focuses on applying modern technologies to improve agriculture productivity and sustainability. These are the contents we are going to see. Introduction. Agriculture depends heavily on plant health. Even a small disease, if not detected early, can spread across the entire field and cause serious crop loss. Traditionally, farmers detect diseases by visually inspecting leaves or consulting experts. This method is slow, subjective, and not always accurate, especially when early symptoms are very small. With the growth of AI and image processing, computers can now analyze leaf images and detect patterns more accurately than human eye. This project uses convolutional neural networks, which is deep learning model, especially good at extracting images and understanding the images. Problem statement and objectives. The main problem is that manual disease detection does not scale. Farmers may not have enough expertise to identify disease early to correct the correct the task. Early symptoms often look similar across diseases, making wrong diagnosis common. Monitoring large farmers manually is almost impossible on early detection and daily tasks. So, the objective of this project is to build an automated AI system that can take a leaf images as input, analyze it using CNN, accurately identifying whether the plant is diseased or not, give results quickly so farmers can take early actions. Existing system and limitations. Existing systems mainly depend on manual observation and simple disease image processing rules like colors and thresholds. These methods fail when lighting conditions change or when the disease have complex patterns. They also provide and they cannot provide real-time results and are not suitable for large-scale deployment. Hence, there is a strong need for an intelligence automated and scalable solution, which is where CNN based deep learning model becomes useful. Scope of the project. This project can be used in real world farming scenarios. Farmers can upload leaf images using a web interface and get instant disease prediction. It can also help agriculture research centers to collect diseased data and to analyze the trends. Overall, it supports the idea of smart and precise agriculture. Methodology. This is how the system works. First, a data set of leaf images is collected containing both healthy and diseased. Next, the images are pre processed. This is very important because neural networks require uniform inputs. Images are resized, normalized, and cleaned to remove noises. Then a CNN model is built. CNN models automatically learn features such as edges, textures, and disease spots from an image. The model is trained using label data, so it learns which patterns correspond to which diseases. Finally, the trained model is evaluated to check its accuracy before deployment. Architecture diagram. This diagram shows the overall flow of the system. The user uploads the leaf image. The user analyzes it through the front end. The image is sent to the Flask backend where pre-processing is performed. The pre-processed image is passed to the CNN model where the prediction of the disease is occurred. The result along the confidence and recommendation is written to the user using frontend. This modular architecture makes the system easy to maintain and scale. Design diagrams. The use case diagram explains how users interact with the system. The class diagram shows how backend components like model, users, and prediction modules are structured. The sequence diagram explains the exact order of operation from image uploaded to result display. This diagram ensures that the system is well planned before implementation. Algorithm and tools used. This is the heart of this project is the CNN model. CNN is the ideal for image-based tasks because it automatically extracts important feature without manual programming. Softmax is used to convert model output into probability values and it classifies the images. Tools like TensorFlow and Keras help in model training, which Flask helps deploy the model as a web application. Implementation. Leaf images dataset and collected to prepared, image processing applied, and the CNN model design using trained input data, API routes created for image upload and prediction, front-end interface developed for user interaction, prediction and results are shown using the front end. Important code segments. This is the important part of this project. Instead of writing manually rules, the code are pre-loaded and the CNN models trained it as a pre-trained model. When a user uploads an image, the code pre-processes it to match the format used training model. The CNN model then analyzes the image and extract features like color variation, textures, and spots of the diseased patterns. The softmax layer gives probability scores for each diseased class. The disease with the highest probability is selected and shown to the user as a diseased image along with the confidence. This automation removes human error and makes disease detection faster and more reliable. This is the main related code for this prediction of plant disease. Uh, Importing the required libraries and we are pre-processing the trained images. The model CNN model is created and the disease prediction function is created to detect the diseased images of the leaf and the class is called to predict the function. Test cases and result. Multiple test cases were executed to validate the system. Valid leaf images produced accurate disease prediction when invalid inputs were handled properly. The model achieved 95.2% accuracy, which shows strong performance and reliability in real time usage. These are the output of the web interface. The page of login ensures access to be secured. The dashboard provides easy navigation. The system direction page displays the predicted disease, confidence score, and the recommendation action, making it user friendly for even non technical users can be used easily without any difficulties. Here we are entering the username and the user password to create. If it is not signed in, we can create an account. This redirects you to the dashboard page. Here we can go to the detection part. Here we upload the dataset as it is the leaf image and click predict to get the prediction accuracy and what is the defect name. Here is the defect name.